this again. We have our, today we're finishing up, should be finished with and have turned in by the end of today at the very latest, all of your stuff from the motor project. And I showed my motor to the students earlier. The motor that I did looks like this. Let me show it to you. If you look on Google under simplest motor, it's not going to take me to Google. Oh yeah, it is. This is what my motor looks like. It's I used a nail, but they use a screw here, and it's got a magnet on the bottom, a wire connecting one side of the battery to the magnet or the screw, and that screw will actually turn and turn and turn. Much easier to show it here than goodness, I can't tell you go back. Much easier to show it here than I can show it on the camera. Better video of it. Now let's see if I can find another good. Let's see if this is a good video of it here.
Let us begin.
Hello, this is Hank Green, and welcome to another SciShow experiment. I have in my hand a small disc magnet, a D battery, a piece of copper wire, and a drywall screw. With those four objects, I'm going to build an electric motor just powerful enough to make this screw spin, but also strong enough to blow your mind. Start with a magnet. I'm using a neodymium magnet because it's round and thin and very powerful and plated to conduct electricity. Attach it to the flat end of the screw. Then with the magnet attached to the screw, turn the battery upside down and touch the screw to the little node thing on the bottom, and it should just hang there. Then hold the copper wire to the other end of the battery and ever so carefully touch the magnet with the other end, and magic. If you can hold it in place for 20 seconds, the screw will be moving at 10,000 revolutions per minute. It's the world's simplest electromagnetic motor, known as a homopolar motor because it works without having to reverse its current like most other electric motors. It may not be pretty, it's definitely not efficient, and it doesn't have many practical applications, but this little contraption does demonstrate the concepts that make every motor work. An electric motor simply converts electrical energy into mechanical energy. In this case, we're using the energy in the battery to create rotational motion. Like all motors, this simple motor uses magnetic fields to create the motion with the help of something called the Lorentz force. You gotta remember here that electricity and magnetism are the same force, electromagnetism, that we just happen to notice and describe in two different forms. When a current flows out of the battery, it creates a magnetic field around it. And by the same token, this magnet was permanently magnetized using a ridiculous amount of electrical energy. You can't have electricity without magnetism. They're the same thing. So when you combine an electric current from a battery with a magnet, you're basically creating two overlapping magnetic fields. And when these fields interact, they create the Lorentz force. As Dutch physicist Hendrik Lorentz calculated in the mid-1800s, this force is exerted on the charged particles that carry the electric current at a precise right angle to the direction in which they're flowing. In other words, the Lorentz force is applied perpendicular to the current. So when you connect the copper wire from one end of the battery to the other end of your motor, you're completing an electric circuit. You're allowing the flow of particles from one of the battery's electrodes to the other. In this case, the current is flowing from the positive electrode, or the top of the battery, even though it's upside down the screw, out the side of the magnet, and then back through the wire to the bottom. Basically, the current is running down the motor's axis of symmetry. But because the current is flowing through an additional magnetic field given off by the magnet, the Lorentz force pushes those particles at a 90-degree angle, forcing them to move perpendicular to the axis of symmetry. This force on the charged particles inside the screw is what makes it spin. All electrical motors work on this same principle. But even though this motor is a good way to see the Lorentz force in action, you won't find many applications for it. That's because it's producing a continuous flow of current, which will drain this big old battery pretty fast and also get it pretty hot. Most battery-powered electric motors, like you'll find in toys and other gadgets, use a series of coils to create and amplify the magnetic field instead of a permanent magnet to make it more efficient. So not very efficient, but very simple, and also pretty cool. If you have any other ideas for experiments we could do here on SciShow, you can leave them in the comments below. We'd love to have your suggestions. If you have any questions or comments, we're on Facebook and Twitter, and of course, down in the comments below. And if you want to keep getting smarter with us here at SciShow, you can go to youtube.com/SciShow and subscribe.
So that's the most simple motor I could ever come up with. It's a good one, I think. He's quite a nerd. Quite amazing. Anyway, so that's the electric motor, and that's that project. You should turn in a logbook and a video of your motor working. Logbook including all the stuff that you did to research, to design, to build, to test, and everything else on your motor. Then, when you're done turning in the stuff for that project, the next project is the radio project. And that's where we go to scitoys.com. And at scitoys.com, you can, let's see, here's scitoys.com. They have a section here, science toys you can make with your kids. Go down here to radios. Radio, and there's a bunch of things here under the radio section, I guess you could call it. And I would go to build a portable crystal radio, I think is the one that we're doing here. And they talk about how they've done this. And it's a little more complicated than the one we're doing because they make their own inductor here. And I actually provide an inductor for you. But they also use a capacitor, which I provide, and they've got a big knob on their capacitor, so it's easy to turn it. And they're using the diode crystal that I also supplied. And they have alligator clips, which I supply, which is nice. And then they talk about soldering it all together, and the earpiece I supply the earpiece as well. And then they point us to the kits that they have, and then I can show you what I'm actually providing you exactly. Because this is the kit that I bought for you guys. Right here. Simple crystal radio kit. So you should have one of these pieces of ferrite with the copper wire wrapped around it. You should have a variable capacitor and one of these diodes. It's got, looks like this little round thing, tiny little round thing with two wires poking out, one each end. And then you should also have an earpiece in there. And using this website and learning what you can learn on this website and whatever other website you want to use, you should be able to build a working AM radio that you can actually tune into an AM radio station. So your mission until next Wednesday, before next Wednesday, is to make a radio and be able to tune into a radio station. You're going to keep a logbook. Always you're going to keep a logbook of all the research you do, all the design you do, all the work you do, and all the testing you do. Then you're going to also make a video of your working radio. Make a video of you listening to a particular station on your radio. You should be able to get it. It should be loud enough that if you hold the earpiece up to the microphone on whatever you're making the video with, a camera, a phone, or whatever, that I should be able to hear it. So make sure that happens. Besides that, I can't think of anything else we need to do for next week. You have a couple of days to work on this, today and Monday, turn it in by next Wednesday. And next Wednesday we may do one more thing with the radio project. So see how that goes. So, promoter project done and turned in by the end of the day. Radio project started, turned in by Wednesday so we can talk about more projects. Have a good weekend, and we'll see you later.
Yeah, I'm having a little trouble with the motor project. I couldn't find those magnets.